Okay. Hi. I'm coming to you from my Sunday evening work time to do a little lab with you. Obviously, ideally, we do this lab together. There's a lot of materials, so it made a lot more sense for me to just walk you through it. You guys are going to do some observations and think about what it means. So I'll start by talking to you a little bit about lab setup. So this is lab setup's maybe what we call like janky. But it'll do the trick for us. So I'm gonna tilt my camera down so you can see kind of what I got going on here. Got a messy desk, right? Totally a human. So I have inside this tube a flashlight, small flashlight. It's in here just because it helps make sure that the resulting light is a nice, perfect circle. That's really important for what we're looking for. And then it's just propped up on a box that is just there to make sure it's at the angle we want, because we're going to be using a piece of paper to measure that circle through this experiment. This flashlight, this tube, is taped to my desk so that it stays in place, because we want to make sure that the paper that I'm lining up with the edge of my desk is consistently the same distance from the tube over time, because that'll be really important. So that tube, the light coming out in this is representative of the sun, and it's going to help us understand a little bit about solar radiation on Earth in different parts of the Earth. So we're going to start with red, because this is not true. So what we want to measure is how we know that Earth sits on an axis that is tilted, right? So it's not 90 degrees, it is 20 something, I think, off the top of my head. Google it, house cut points if you can tell me. So I'm going to start just leveling my paper here, right, with the edge straight up and down. And then obviously you guys can't totally see this, but what I'm going to do is trace the outline of the light that I see. And I'm going to try not to hit the thing, because that's not going to help me. Okay, this is probably not going to be like perfect here, right? But we're going to get the idea. Ooh. Right, guys, Miss Camp is not an artist for a reason. But I end up with like see if this will focus, a pretty circular circle, right? Well, it might not be perfect. So what I want to see is, I notice that when the sunlight shines directly on a piece of paper at a 90-degree angle, the entire area where the light hits gets an equal distribution of the light. No part is getting more direct light than the other, which is why you get equivalent brightness. You can sort of see this back here as well. The brightness is pretty much the same in the entire circle. So what I'm going to do next is I'm going to move my Earth at an angle, and that's right, Miss Camp actually studied math in college, so I used to have a protractor, and I searched deep and wide, but I don't have it. I have a handy dandy iPhone. So I want to measure the angle, right? Because this is a precise experiment, and you guys are going to want to collect some data on this. So I'm going to line this back up right where I had it before, give or take. Okay, and then I'm going to use my phone. We're starting at 0, and by placing my phone against this, I'm able to tilt it back with my phone. I'm going to tilt it till I'm at about 10 degrees. Okay. I'm going to try to hold this mostly even. Obviously, human being might not be perfect. I'm going to grab a new angle, a new thing. I'm going to retrace my circle here. getting really with the lack of art skills. So switching colors, we're gonna do the skin. So I got a different color pen, just so, and I'll mark that was 10 degrees tilt. So I'll line it back up with my original. This time we'll double that tilt to 20. Okay, and we'll go one more, we'll double the tilt again to 40. So you should probably be noticing as I'm drawing, right, kind of what's happening. Start it over because this slipped a little. So let me see if I turn the light off and you can really see this. So as I tilt, one of the things I start to notice is that the light that is further away on the tilt becomes less bright, right? So you begin to notice some fading, and the brightest point of the light is down here, which lines up with the circles that we draw, which I'll put a picture of this for you guys too, as it focuses. So you have your most circle and then it becomes elongated, remembering that the focal point of that light was here. The last thing I'm going to show you is what does that mean if we think about a globe? So I happened to buy a globe once at TJ Maxx because I thought it was cute. So this works out for us. So if I look at my globe here, right, my globe sits on a tilt. Okay, so I'm going to turn this globe so that the tilt is facing away, right, and the bottom of the axis is closer to us. So notice this line right here where my finger is. This is the equator. Where does the most direct sunlight hit on my Earth? Right now, the most direct sunlight is hitting toward the equator and the southern hemisphere, meaning that in the southern hemisphere at this tilt, it is what season? Summer. Great, greatest Olaf impression. If I flip it the other way, right, where my tilt is leaning toward my light, now my equator is actually down here. See if we can find New York. New York's right there. So now it is, or this is North America. Now it is summer in North America. So the important idea here is that the disbursement of solar radiation at an angle lessens the intensity of that radiation, right? As I moved my paper back, there was less sunlight going up here, which meant the farther you are, not like the planet itself is not moving, but the tilt of the Earth causes some sunlight to hit more directly, more intensely, causing warmer weather. As that tilt flips when the sun, right, because the sun is, the Earth is rotating around like this. So if this is the tilt, sometimes the top is tilted away. sometimes the top is tilted toward. So as the sun makes its yearly rotation, you hit points where the northern part is tilted toward the sun, and then an opposite point where the southern part is tilted closest to the sun, causing what we know as seasons.